So, hello and welcome everyone to Awesomeness of ELM, and I hope that you will learn something new today. My name is Yanis and I work here as a software engineer at Diatom, and if you need some social information, my blog, Twitter, GitHub, there it is. And let's talk about agenda. So I wanted to start at 11, but we are 20 past 11, so it's going to be introduction with slides, and somewhere in half an hour we're going to start the workshop. So then there's going to be pizza break and final part of the workshop, and after that we're going to go and conquer the world and get some profit out of it. Alright, so what is ELM? Well, ELM is a purely functional, mutable, and domain-specific language. What does that mean? Well, I'm going to try to explain that in this presentation. And the basic gist of ELM is that it catches all possible runtime exceptions with help of the compiler. So its syntax is heavily inspired by Haskell, OCaml, and ML. Has anyone worked with like a purely functional language before, or a functional language in general?
You mean like Haskell?
Well, any functional language. I mean like Elixir or Clojure or any other awesome.
A little bit touched Haskell, a little bit, but I'm trying to avoid this functional.
No, but actually functional languages are awesome, and I hope to prove that today. So yeah, this is so Haskell is known for its like unapproachability, I would say. Like it's super academic, and everyone is trying to like tell you that you need to learn a million of theories before you can actually begin to program in it. But ELM has taken more of a pragmatic approach, where it's a functional language. It's a pure functional language, but still it has all the benefits, I would say, of like being human readable and human understandable. Alright, as a first thing, I would like, since it's a functional language, I would like you to check out these few functions. So, as you can see, like isPositive is a function name, and n is an argument. So you don't see any parentheses or anything like that. That could be actually distinguishable from, like, you don't see anything familiar here. Well, the syntax is inspired by Haskell, and this syntax allows pretty easily to do partial application, which I'm going to explain in a moment. So yes, you basically write a function name, you supply its arguments without any commas, without any parentheses, and the function body goes down, and then the last thing that is executed in this function is a return value. At the top you see basically a type definition. So what is a type definition? It just states that what kind of arguments it accepts and what kind of return value do you get. This first line is actually optional, so it helps you and the compiler to understand what you actually want from this function. So let's get to another function which is bigger. So here you notice that the type definition is int bool. That's also a feature of partial application, which I'm going to explain in a moment. So again, we see arguments supplied without any commas or parentheses, and the last thing that is executed in this function is a return value. So what is partial application? Has anyone touched bind with JavaScript? So basically it says, you just say that these arguments will be supplied at a later time when we execute this function. This is very similar. So for example, like add takes two arguments and produces result. So add2 actually partially applies only a single argument, which is 2, and then you can supply another argument to that, and only then you get the result. So the idea is that it generates another function, and as you can see, one of the in its type signature, one of the like ints is gone away because it returns a function that only expects one argument. So yeah. The next thing I want to talk about is this notion of functional composition and all the things that are related to strongly typed functional languages. If this doesn't make much sense at the moment, we're gonna, in the workshop, I'm gonna answer all the questions that you have, and we're gonna try to get to the bottom of all these things. But yeah, bear with me. So basically, there are a couple of ways that you can write a function in ELM. So the first one is like reverse and repeat greeting. It accepts a string and returns a string. Sorry about that. That's a formatting error that I had. That shouldn't be there. It's all right. So string reverse accepts the result of string repeat that accepts two and a greeting. So as you can see, it's quite similar to any other language in terms of the parentheses, where you put things in parentheses that need to be executed first. So for example, string repeat 2 greeting will return a string that is repeated 2 times, and the result of that will be passed to string reverse. And string reverse will just reverse the thing that you passed to it. The second thing is more readable option is to pass, for example, string repeat 2 greeting to string reverse with pipe. So what is a pipe? Pipe is it allows you to pass a result of a function to another function. So you see, for example, string dot reverse. You don't see any arguments there. So what you actually the argument on the left side of the pipe is string repeat to greeting. So the result of that is an argument to the next function. Has anyone seen this sort of syntax before? In any other? I'm not sure about Haskell. I haven't touched Haskell like for a couple of years now, and I don't really remember. But Elixir also has this pipe operator. So basically, the idea is that you can chain multiple functions together, and it just works. So for example, one function executes and it passes a result to another one, and this function executes its pipe, it passes a result to another one. So this is quite awesome when you can like link things together. Yeah, and the last one is like reverse and repeat greeting. It's basically a composition function. So ELM allows you to do, since it is aware of all the type signatures for the functions, you can basically combine them together in a single function. And if the result of this, so on the left side you see string repeat 2, which is partially applied function. So you need to pass a string to it to be to return a string, right? And string reverse also accepts a string. So what you do here is you combine those two together, and these two together form another function that you can pass greeting to, and it will go through this chain and produce a result. And compiler will know that this is basically correct because you know all the type signatures. I know this is like loads of information, and it's probably hard to follow at this moment, but it will make more sense when we start actually coding in ELM. So another feature of ELM is what is called union types. So union types allow you to basically create a type from multiple types. And what does that mean in practice? Well, that means if you want to unwrap Boolean result, you have to handle all the cases. So, for example, needs greeting is a Boolean that we pass to say hello function. And if we want, okay, you can use true and false as a regular, like in regular if statements, right? But still, here is a basic example of a union type. So what you do here is you you do a case statement on this union type, and you have to handle all the cases. So in this particular instance, you only have true and false. And if we pass like true to it, it will return hello. So if you forget to pass false, it will complain. It will say that not all union type cases are handled. At this moment, it also doesn't make much sense. Why do we need union types in that here? But here is a result, here is an example of where they are getting really useful. So for example, let's say we have a type of name, and something can be anonymous, and something can be present. And present actually accepts a payload of a string. So the same example, we have a case statement on name, and we have anonymous as a first thing we need to handle, and we just return a string, hello guest. And the second one is present, and it has a payload of a string. So hello and present name in this case. And at the bottom you can see the examples. So for example, if you pass say hello the anonymous type, it will return hello guest. And if you pass to say hello present and name Yanis, it will return hello Yanis. So basically compiler just ensures that you handled all the cases for this particular type correctly.
Okay, and if you will throw there like nothing, you will complain. Yes.
Meaning? So
If you will, okay, so your function say hello now will receive one argument,
Mhm.
the name.
yeah.
If it will be, yeah, it only can be of a specific type.
Yeah, it only can be name type, right? So here we have defined the type name, and if you pass anything that is not a name, ELM will complain and will not allow you to compile your application, basically. So it's
Strings are not acceptable entities.
strings are acceptable. It's just a showcase of how you can do things. So for example, like strings can be anything. I'm gonna actually show an example of having this type of behavior a little bit later on, but basically, let's say you have different states of user. I don't know, he's blocked, for example, or he is admin, or he is something else. So you can define specific types for each user. And each time you need to, for example, unwrap this user, you will need to handle all these cases. Like, okay, so it's a guest and he has this payload. Okay, it's an admin and he has this payload. Or the payload can be also the same, right? It doesn't matter. Like you can, but if you want to unwrap it, you have to handle it. Like, yeah. So. To the next topic. Tony Hoare is a principal designer behind Algo 60. So he calls it his $1 billion mistake. So does anyone know what he's referring to here? I guess, like, what's the most common error that you actually have in your applications?
Type mismatch. I started it.
Usually with pointers something.
Well, it's null reference, right? So how many of you have seen something like this, like this, like this, this? No, definitely in JavaScript, but well, I bet like you see this mistake every day, and somewhere there's a null reference that that has gone astray. So this is where maybe comes in. Maybe type is something that allows you to handle a thing that can be nothing. So for example, if we want to have something that is that can be, let's say, nullable in a regular application, we usually check for it. So let's say, like, I don't know, user is not present, and then and then we just return I don't know, anonymous and things like that. But maybe is combination of it's a union type of nothing and just a value. So in this case, A is a custom type that you can specify to it. So like in C#, for example, you have generics. Think of it as a generic. And you can pass any type to this maybe. And here again, we have a case of show username. And you pass it a name. And if it's a nothing, we return a guest. And if it's a just with a value, we just return that username. So, and in type signature, you see that there's a maybe string here. So, and the result will be a string. So each time you want to unwrap like maybe, you have to handle again both cases. So this is also a union type, as I mentioned before. And this is where some of the most programming mistakes are handled with ELM. So it's maybe. Maybe sounds nice, right?
Maybe.
So again, Joe Armstrong, creator of Erlang programming language, said this cool quote about object-oriented languages. You wanted a banana, but but what you got was a gorilla holding the banana in the entire jungle. So we really do not know what is happening in our application if we do object-oriented programming that allows for side effects. So what do I mean for side effects? Like, for example, you can call an object, it can write to the database, it can call HTTP, it can, I don't know, read some kind of user input, or it can do anything that, yeah, basically you don't know. When you call an object, you don't know what's happening in there. And this is, of course, this is like a case for JavaScript. Like JavaScript can do basically anything. Like it can blow up, it can make an HTTP call, it can. Yeah, it's just amazing. So, and for example, if we pass a user object into add default last name here, what will actually happen? Do we know? So will it have mutated this object by reference, user object by reference, or did it I don't know, create a new value, or what happens here? So no one really knows. Like it's a mystery if you don't get into the source, and you don't really know. Like it can be anything. So how does ELM handle this? Well, the basic idea is that each time you modify a value, it returns a new value. Like 90% of concurrency issues can be handled with immutability. So basically, if you want to change something, you return a new copy of it. And that allows for a lot of things to be fixed. Like let's say we have like a JavaScript stack, and it just calls something, and when it returns, it modifies the value on top of the scope, and then like something else calls it and again modifies the value, and it's just a nightmare to deal with. Okay, things like React maybe with Redux help you with some of that stuff. Maybe you can add something like immutable, which would be a good idea. Immutable.js, I mean the library, but still you are not really sure what is happening there. So yeah, basically always return a new value from when you modify something. All right, and what is the notion of a pure function? Well, basically a pure function is something that can accept values and return something else in the result. It doesn't have any side effects, it doesn't do anything. It just modifies the input and returns the output. So pure function basically just heats up the processor, right? And I'm gonna explain how we deal with the side effects in a moment in ELM. So can anyone spot 5 things that can go wrong here? This is JavaScript, by the way. Sorry for bashing JavaScript. It's just a shitty language that I can really bash really easily.
This is the first point. What can go wrong? JavaScript. Everything can go wrong.
But let's take a guess, like without bashing JavaScript too much. Well, let's bash JavaScript.
What problem is
Yeah, so basically that's correct. So first thing that can go wrong is that you have to supply tasks with a specific type that might not be there, or it can be undefined, or you can just simply forget to pass it. Like it's there are a million things that can go wrong here. So alright, so tasks basically can be something that can go wrong. So for example, if you pass tasks as let's say it's undefined. So what will happen if visibility is all? It will return undefined, right? So what is if tasks are completed? It will blow up. So what is if not completed? It will blow up again. And again, if visibility is not one of those all completed and not completed, what will happen then? It will return. It will return undefined, right?
So, in the best case.
Exactly. So again, what would happen if one of the task properties is misspelled, like completed? For example, like you pass array with tasks, and one is and you misspelled completed to complete, for example.
no, also some error. There is no such value.
In this case, there wouldn't be an error. So in this case, if you have completed, it will return none of the tasks because it's undefined, and not completed will return all of the tasks because undefined, the reverse of undefined is true, right? So
Okay.
fun.
Sounds like bullshit. Sounds like Java. Never gonna try it again. Okay.
So yes, these are the things that can go wrong here with this little function. And it's only like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code, and 5 things can go wrong here. So it's just amazing, the things that we have to deal with. All right, so let's say we have a strict typing like an ELM. First of all, you can define visibility as a union type, as I mentioned before, right? So it can consist of all completed and not completed. And a task is a record that is a typed record. So task basically has a completed field that is a Boolean. And it cannot be anything else. Like you cannot pass it I don't know, something that is that doesn't have Boolean, or basically you are sure that completed will always be a Boolean. And so let's pick apart the same example of filter tasks here. So first of all, you need to pass visibility, which is, as I mentioned before, a union type, and you have to handle it. So you have to handle all the cases here. If visibility is not a one of these types, the compiler will complain. Again, the second argument is list of tasks. So if it's a list of something else, it will fail to compile. It will complain to you. If you have misspelled completed, then it will complain to you. And let's see how it actually does it. So let's say we missed not completed. So what will compiler say? So it will say that this case does not have branches for all possibilities. So you need to account for following values. Main is basically a module name. Not completed is not handled here. So the compiler will just provide you with a friendly error, and it will even supply you a link where you need to look and read about this specific error. So it's just simply amazing. Then, what if we misspelled completed? We just said task.complete. Again, hint, just look at the last line. So basically compiler says, looks like a record is missing the complete field. Maybe it's a typo. So perfect, it just says what has gone wrong here in this particular function. Let's get this out of the way, because everyone asks like what will happen if you divide by 0. So basically it will return infinity. That's one of the first questions I usually get asked. So how does it handle like division by 0? It just returns infinity. So we spoke about side effects, this ugly monster from Star Wars that just does everything in your system and you do not control it. So how does ELM handle it if it only has pure functions, like it doesn't interact with HTTP or anything else? Well, the idea is very simple. We have an HTML and we pass a message to ELM runtime. What is an ELM runtime? Basically, it's a magic box where everything happens. So HTTP, any side effects, anything else that you need to do, like you just supply ELM runtime with the things you need to do, and basically it messages you back on an update function, and update function then returns a new model to HTML, and HTML re-renders itself. So this is really similar to what React does with Redux. So basically you say you pass a Redux a particular function, it executes it and it returns a new message, and then this message like goes and supplies you with a new model, and then you just re-render things that you need to re-render. Okay, so let's say we have a HTTP call. So what you do is, let's say you have a button that needs to preload something. So first of all, you will pass a message from HTML to ELM runtime. ELM runtime will call an update function, and update function in return will call an async event to ELM runtime. And once ELM runtime has executed, it again will pass a message back to update function and back to HTML with a new model. It's gonna make more sense when we start working on it, but basically the idea behind Redux is taken from ELM. So something that updates your storage is in single place, and the model that you get is responsible for like rendering all the HTML. All right, so let's see how HTTP call is handled in ELM. So first of all, like let's say we call get GIF message from HTML somewhere. So what does that mean? So it will basically just return the model. So you don't have to do anything with HTML at this point, and it will send the message get random cat GIF to ELM runtime. So what get random cat GIF consists of? So of course you see a URL there where you can get cat GIF, and the command that you send to ELM runtime is http.send, and the http.send accepts as a first argument the message that will be returned when you executed this function, this message, and the second argument is basically specifies what you need to do in order to send that message. So here what we have is we want to do an HTTP GET call with the URL, and we want to decode this specific JSON structure that we will get returned from this HTTP to get data, image URL keys from the JSON response. I won't go into decoders in this presentation because it's a really hairy monster and it takes several days to understand it. But basically what we see here is that we need to get fields data, image URL, and decode it as a string. So, and then once it is all done, ELM runtime will call update function again, and we will return new GIF message. And there are two possible values that can get returned here. First of all, it's okay with a new URL. So a new URL will be this new GIF URL. If you get return with OK and the result is a string, you will always get the result as a string, right? You won't get any errors, unexpected errors. So basically this means that first of all it made HTTP call and then it parsed the result into a string. So here it is. So you just supply a new GIF URL to model, and it will update the DOM as you want. And if it's an error, if it fails to parse or it fails to do an HTTP call, it will just return an error. In this case, we are not doing anything with it. We just supply the same model back to HTTP, and it's just nothing happens basically. But here you can actually handle this error message any way you want. You can supply, you can, I don't know, show a message or anything else. But in this case, it's just nothing will happen. All right. So let's compare like ELM to React. So they both have virtual DOM. They both have unidirectional data flow. Well, with React you can do all sorts of amazing things that you cannot predict, but still they both think in unidirectional data flow. ELM. So the differences are that ELM is strictly type pure language. Compiler will yell at you if you've done something wrong, and it can prove that you've done something wrong. Well, with React it's JavaScript, and I think I bashed JavaScript enough already. ELM is fully immutable, so each time you modify data, it will return you a copy of this data. With React you can do immutability with immutable.js, but it still can produce some unexpected results just because it's fun. Okay, so I guess this is more of a problem for ELM than anything else, but it doesn't have any access to DOM. So for example, you cannot say, give me please the coordinates of this specific element in, for example, to display a tooltip. You cannot do that. You will need to write a port to JavaScript that will basically get this element from the DOM and display it. Yes, React of course has access to DOM if needs be. You can just pass a ref and then do anything that you want with it. Well, with ELM you have a small set of libraries, and that's a little problem. But in reality, most of the things that we usually work with are handled. So with React, of course, you have everything. You need Bootstrap, like just plug another JavaScript library in, and everything just will work. And well, not always, and not in most of the cases, but a lot of things just work. So in ELM you don't have any runtime errors. Well, with JavaScript, it's of course there is no comment about that. Yeah, and now it's demo time. So I'm gonna make this a little bit bigger. Do you see it well?
Yeah.
Awesome. So here we have our code. Let me exit here. And let's do yarn dev. Everyone is able to open that? Cool. You will have to write some code now, so get ready. So when you open up localhost 3000, you should see hello world here. Does everyone see hello world? You did it too? Awesome. And you? Oh, okay. We can begin. So this is basic ELM application. So basically there's a main function that just returns the text of hello world and the result of what we can see in our browser. And the first thing that we're gonna do here is we're gonna create a basic ELM architecture app. So it actually consists of HTML program. Whoa, no.
It was too fast.
Yeah. So
this HTML program is something that it's like library in ELM?
yeah, basically it sets up all the ELM architecture. So the thing that I spoke about before, right? There's an update and there's HTML and everything else, ELM runtime, and I'm gonna explain all those bits in a moment. So basically, it's as you can see, like compiler already complains to me that I haven't supplied all the necessary arguments. Let's start with something really basic and let's create a view function that accepts a model. And it will just return a div with no attributes and a text of hello world. So this will be, the output here will be the same. The difference is that it will have div in it. And let's apply this argument here to HTML program. So view.
Okay, so text here about this div.
Yeah.
This is some special function?
Div basically is, yes, it's a function that returns div HTML.
Yeah, and it accepts like two lists.
Two lists, exactly. Yes, two lists. The first list is a set of attributes for HTML tag, and the second one is like children for this specific tag. It's also a list. So, for example, you can say text.
So basically, in this case, in this list, you specify like named parameters. So you specify like in the property of this text, you will put hello world. In the second list.
So second is basically children of div. So like if you
so you can specify their text, you can specify their div.
yeah, exactly. Exactly. Text basically just states that we want HTML text from a string. It's a thing in Elm that you just cannot pass a string there. Like it will complain. And this is this actually all these divs and everything else is done by HTML module. So everything that you see here is actually imported from the HTML module. This. So again, has everyone finished it? This piece of code. All right. So again, we don't have initial state here. We don't have subscriptions, so we won't touch subscriptions. It's just a basic way of communicating, like from something that needs to happen on regular intervals. Like for example, if we want to set up some sort of time ticker, it will be a subscription that will notify our update function that we need to change something. But we don't need that at the moment. Ooh, subs. Subscriptions are just gonna copy it over. Sometimes editor trolls me, so we don't have subscriptions defined. So let's define that, and it's gonna be subscriptions, and it will return subscription nothing. And yeah, it doesn't have a type model and it doesn't have type message, but we're gonna define those shortly. So the next argument for HTML function is update. So update is the thing that will actually update your model. So think of a model as a thing that holds all the state, and update will update this state in order to reflect that to DOM. So update basically accepts command and message and model, and we're just gonna return model and cmd none. So we don't after executing update, we don't say anything to ELM runtime. So basically it calls update function, it returns a new model. It will be the same in this case, and command.none will say to ELM runtime that we don't need to execute anything at the moment.
So in this case, the function update will return like two separate values? or this is because this is not a list?
So this is not a list. It's a how it's called? Huh?
Tuple?
Yeah, it's a tuple. So basically, first element of the tuple is model, and the second is a command that you might want to execute or not. So cmd none in this case just returns that we don't need to do. We say to Elm runtime we don't need to do anything after this update. And one last thing is init. So it will be initial function with initial state. We don't have that, but let's define it. And here what we can do is just return a 0 at the moment. So right now it complains that we don't have model type and message type, so let's just do that. So message type will be something that is responsible for handling different types of messages. So let's define that. Type msg is equal, and at the moment let's just say it's going to be equal to increment. And our model will be a simple integer. And again it complains, so basically it says that the init function is expecting argument to be a model and the command message, and we just can do, I think, like this. Nope. Okay, so we just need to do it. We need to supply a tuple with a new model and cmd.none. And again it complains. Number. Okay, let's just say init, and let's define the type here. So it's just going to return a tuple of model and msg, cmd msg. But the definition shown above is a okay, I forgot to add type alias. So now it works. Sorry about that. And if we refresh our page, it's still gonna display hello world. And let's just add bang symbol here and see that it changed. Well, let's add something more. So as you can see, it compiled and everything just worked. So the first exercise that we're gonna do, like create an actual interaction, is we want to increment our model and display it. So for example, we will have two buttons, increment and decrement, and our current counter that can go +1, -1 each time we click a button. We already supplied the message increment here, so let's implement that. So first of all, let's display the value of the model that we have. So by the way, if someone didn't manage to write all this, you can basically check out to version 1, git checkout v1. Okay, cool. So let's just display the name of the model. Alright, so our model is an integer, so we need to convert that to a string to pass it to a text function that will display it as a text. So the way we do that, we open parentheses to string and we just supply it a model, and we should see 0 here. Yeah, so 0 is here, and it's our initial state of the model. So let's create another div tag alongside of it. Div, and since it's a list, we need to add comma here. And let's apply another div. And actually, let's create, and as a child of this div, we're gonna create an input that basically a button. So it will have a type of button, and as a value it will have increment. So it cannot find variable type, it's just because we don't have HTML attributes imported. Attributes, I think, right. So we can see increment button here. And let's just add another decrement button. So does this syntax make sense at this moment, or are you confused by it? Should I explain? Mm-hmm.
How we created all these div input things.
Exactly. So basically, just to go through it, like we have a root div that has no HTML attributes, and its children are div with input as a child. Then we have a text that displays our model, and then again another div with another button inside of it. And why like type here is with underscore? Because like type in Elm is a reserved keyword, and you cannot just say type without breaking Elm. So and yeah, this is as simple as that. So what we want to do here right now is we want to, for example, when we click on increment button, we want to actually increment the value of our model. So let's do that. So what we can do is we can say on click, we can say increment. So on click is not here. We will need to also add another package, HTML events. And on click should work now. Alright, so here comes in this case statement that we spoke about previously. So we can say case of, and in this expression we can say increment, MSG, and here we can say increment. Since it's a single type, basically it consists only of one possible option. Compiler is fine with that. And if we click on increment at the moment, something is happening, but it's not actually incrementing our current state. So let's change that, and let's update the model to be +1. So as you can see, it's incrementing when we click on this button. Alright, and let's actually implement decrement. And as you can see, it starts to compile, starts to complain, sorry. It says, it's the same error that I shown you before, that we don't have decrement handle here. So let's do that. And model -1 and cmd.none. So we're not saying anything to our Elm runtime again, and we just decrement a single value from model. And again on click, let's apply on click here, and let's say decrement. On click, and compiler complains again. Just copy this over. All right, so we can just click decrement now, and it decrements the value.
Can you please explain what the magic happens with on-click stuff?
Sure.
Because increment is the type of a message.
Yes, exactly.
Apply there on the message and update how it's triggered.
Yeah, basically, you saw previously I was explaining this ELM runtime, right?
Yes.
So let me open up the slides, and it's going to be much more.
No, so like all events go to this update function in the HTML program, something like that.
Yeah. So HTML program basically returns all the necessary components for it to be rendered, and for example, in this case, we supplied it with view update function. You can call it anything that you like, right? It's but the argument must be an update and initial state. And the subscriptions, we are not worrying about them at the moment. But basically, what happens is that you, with the help of HTML, like HTML generates a message when you say on-click increment. It sends it to ELM runtime, and then ELM runtime in turn calls update function on our update function. So, and then we generate a new model, and then it's re-rendered in HTML. So, yeah, the moment we have created our, I think, most basic Hello World application in ELM. So, does everyone have a result? Cool. Everything works for you? Awesome. And there's something interesting that you can see here that is happening with ELM. There's a explore history. So basically what you can say, you can see how model has changed. And it actually reflects when you click on specific event, it actually helps with debugging. So for example, if you change state and you see something that has gone wrong, I think Redux has a similar thing going on. You can just install the DevTools and you can basically browse the history and how it changed. But here at least you have guarantees that it actually works that way. All right. So let's continue with our little application. And actually, let's move this a little bit to the top so it doesn't bother us too much. And now what we're gonna do is create a list of tasks that we will display as a to-do list. It's just gonna be a simple display of hard-coded values. All right, let's start thinking about our model at the moment. So what we need to have as a first, like, simple I would say implementation is a list of strings to display the tasks. So let's do that. Let's say entries will be a list of strings, and that's gonna be our model for the moment. And let's actually remove all these messages. Let's add message, but forget about that for the moment. Let's again remove this MSG model and cmd.none, and we can simply remove all this stuff as well. So we are left with a model with the entries that is list of strings. We have one message that we don't particularly care about much, and our initial function complains because it returns a number, but we expect it to be a model. So what we can do here is we can just say entries, and let's add my first task, my second task. So if I, for example, misspell this, it's gonna complain because it expects a model to be returned. And the entry is not part of the model structure or model type. The another option, what we can do here to ensure that it is a model, we can just say model and return the arguments this way. So, for example, like if you have multiple arguments here, you just pass them one by one. Let's say we have another argument, we just say, for example, if it's an integer, we can say 0. But I think this is a little bit more readable. So we have our entries, and let's actually display them. And alright, so we have our main class here, a main wrapper, so to say, and it will be called Todo MVC wrapper. This is the way the CSS is structured. So, and its children are section. So section is HTML5 element, and the section is of a class To-Do app. All right. Has everyone managed to type all of this? Silence? Yes? No? So section has has a couple of elements. It's going to be a header which will contain input field and like main To-Do's logo, I would say. The main section, the main part of the app will have the To-Do items listed. So what we can do here, we can extract a function, not extract, but create a function that will say show header. Let's say, and let's have another function here that shows show entries. So, well, of course they're not defined, but let's define them. So show header has header with the class of header, and as its children it has h1 and a text of to-dos. Alright, so show header is implemented, and let's create our main section, show entries. Actually, we need to pass a model here, since we're gonna use some of the model's entries. And here what we need to do is it's gonna be again a section, HTML5 section with the class of main, and in the main we're gonna have a unordered list. And unordered list will have, okay, so it also needs a class. The class is to-do list, and it, of course, it contains list items. And here we actually can extract another function that will show individual entry. Show entry, and we can do list dot map show entry as a function. So is everyone familiar with the map? So list map as the first argument is a function that will be applied to the list. And the second argument is model.entries, which is a list of strings. Actually, we don't need this because it's going to return a list. Let's actually do it like this. The formatting is weird sometimes. Okay, let's leave it at this. And let's create a show entry. And it's gonna accept a single entry. And it's gonna be a list item. And with text of entry. And it doesn't work. So show entry expects an entry. UL list. So somewhere second argument of function UL is causing a mismatch. So it expects a list of HTML things, but it's actually returning something really weird. List map. Let me double check this. List map and show entry model dot entries. Looks like function needs. Well, these HTML errors are really cryptic sometimes, and it's hard to understand which what has gone wrong here. Brackets. I think yes, you're right. Exactly. Okay. Perfect. Sometimes this happens. Okay, so you can see that it's displaying some sort of to-dos right now, but I think we need to add some classes here as well. So it actually, of course, it's not as simple. So we need to create another div tag in li element that has a class of u. And it has a label inside of it, and label in turn has text of entry. Now we can check our browser, and as you can see, like our basic to-do list of tasks is here. Oh, I actually hard-coded entry here, like this. My first task, my second task. So that comes from the initial state of the model. Now, if you want to go ahead and follow, there's a lot of HTML typing here. Does everything of this, what I just typed in, make sense? So basically, what we just did is we created a model with entries that is a list of strings. We supplied initial model with 2 entries. We removed everything that is an update function because we don't need that at the moment. So we created like a div with a class to do MVC wrapper. It has a child section of to do app, and basically it shows header and shows entries. So in header we have a header HTML element with a class of header h1 with text to dos. So show entries is basically another section here. It's a child of to do app, and it has a class of main with ul. so unordered list with class of to-do list, and the second argument to UL is basically a list of modified entries, and list of for example, list map takes show entry as an argument, and it applies it to every element in the collection. So, and show entry itself as a function just returns HTML li element with a div of view inside of it and a label. So it's quite simple, but a lot of typing. It's going to be much less, I promise you. So if you want to follow along, check out to V3 in the GitHub.
No branch V3 on the GitHub.
Can you pull? When did you do a latest pull? This morning. Should be there.
Yeah, up to date.
Okay, let's quickly check it out. I think it should be there.
I have V1, V2, and then
Okay, I must have. I have V2, V5. So let me quickly commit this to. Okay, I have it, but I haven't pushed it. So okay, just gonna commit this, and you can check out the master. Pull the latest things from master. Okay, you can check out the master, pull latest, and you're gonna be on the same page as I am. Actually, I'm just gonna commit to master after I do each step. Then we're gonna guaranteed that we will have the same code. I think that makes more sense than just checking out the branch that can be slightly different and may cause some confusion. Later, I'm gonna push like from V1 to. So V3, V4, V5 is not there. I'm gonna just push it, and you will be able to, for example, if you want to try it at home, like recreate all the steps that are there. Has everyone pulled master? Everyone's fine? Okay, cool. So the next thing we're gonna work on is basically adding tasks to this list, and what we want to do is we want to have an input field here with ability to press enter and add this task that way, right? So let's do that. So where will this input be located? It will be located in header. So of course. So let's create an input field here, and I have a cheat sheet of CSS classes because it's hard to remember like all of them. Okay, so it's gonna be an input with a class of new to do, and it's gonna have a placeholder as well. What needs to be done? If we refresh this, it cannot be reached because I need to start the server. So basically we added to header an input field that has a class of new to do, a placeholder, and at the moment the input is empty. So here it is. So logically, when we type something, nothing happens. When we press enter or do anything else, it's just a input field. And we have this message of add. Let's do a on enter. Basically, let's make input do something on enter. And on enter is an interesting exercise here because it's not part of like a standard library, I would say, that handles events. Like you have an on event and on key down, but you need to handle how you like which key you actually want, like because enter is 13, and you don't want to handle every possible key. So let's do that. Let's say on enter, and we want to supply a message what we actually want to do on enter. And on enter we're gonna say add. So let's actually define this on enter function. So on enter we'll accept a message, and here we're gonna see the first example of like having some variable like structures in our functions. So we need to, all the variables that we want to use, we need to use let inside of the function body. So and here we want to have like a is enter function. So basically is enter will tell us if this actual key is enter in fact. So, and it will basically have if. So it should accept also, so it should accept the key. If key is equal to 13, then we return JSON success. So the way this works, so for example, when we say on, for example, key down, we receive an event, right? So in JavaScript, we receive an event. An event is basically a JSON structure that we need to somehow parse in ELM, because ELM is strictly typed, and we need to somehow tell like the compiler that we know how to handle this dynamic structure. So we need to parse JSON of ELM, and then with the result we need to basically say to JSON. So as a result of this, we need to have a JSON decoder. If it succeeds, it will return a message. If it doesn't succeed, it won't return the message to our ELM runtime. So here we have JSON succeed, and we send a message, and else we can say JSON fail not enter. And the next thing after let, what we have to do is we need to specify in. So in this function body. And here what we need to do is basically on key down. So on key down accepts following argument. So it's sort of like a JSON parser that it accepts. So as I mentioned before, and so JSON and then basically states that we received the following value. If it has been parsed, please continue with this function. So in our case, this function will be is enter, because we don't want to let it succeed if it's not enter, right? So this is why we wrote this particular function. And the second argument to is then like the basic parser that will take all the events from the event structure and return us the key code is key code. It's from HTML events, basically. It's a library that takes our current event, gets the key code out of this event, and returns it. It's simple as that. So we don't have JSON. Let's actually import it. I know this is like a little bit weird, like JSON, as I mentioned before. JSON, first of all, it's hard to explain in Elm. You just need to get it. It's like 2 days until you start fully understanding how to handle JSON in Elm. It's one of the most, I guess, I wouldn't call it annoying, but it's definitely, you need to get used to it. It's a little weird for us who, you know, just basically specify what we want and we get that from JSON. Okay, we're just gonna say JSON decoder. Decode. JSON decode does not have a success. Give me a second. Succeed, not success. Why? Okay.
And can you please show us the browser right now?
The browser?
Yeah.
Oh, okay.
Will the browser somehow tell us that our application is broken?
You see, you won't be able to compile the code if it's broken. So the browser doesn't tell you anything. Usually it's...
Only compiler will say.
Yeah, only compiler will say that something is broken. So the only time when Elm breaks in production, not in production but in any time, is when you pass like JSON to its initial state. So for example, like you need to pass some JSON from HTML to as its initial state, and if you specify it incorrectly, then it will break. So it will notify you that you have something that is going on and it's weird. So yeah. Do you have also in your text editors, do you see the mistakes? Like does your environment tells you what has gone wrong?
No, I don't. Looks like I only downloaded plugin for syntax highlight.
Okay, yeah, that's why it's weird. You can check maybe the console to see the errors that you're currently having. So for example, Visual Studio Code, like if you install the plugin, it will tell you like exactly what has gone wrong and what you need to fix. This is actually going to be the only weird part about this whole application, because it's as I said, like it's the way that the JSON is parsed here is not super intuitive. The way you do that basically is just take a JSON decoder and return it either success or failure to Elm runtime, and then it's gonna do whatever it wants to with it, whatever you specify to do actually, not whatever it wants. So but here we just say on enter and we supply it a message, and if it's an enter it will send us what we actually need. So everyone has a working copy of the application. Cool. So Visual Studio Code should actually have all the necessary, I think Atom too as well, but you might need to install Elm -make to make that happen. All right. I'm just gonna continue. So we have specified this add message, and we need to handle it, of course. And let's handle it. Case of MSG add. But the question comes like, what we actually gonna add here? Since we don't have anything coming from this particular event, we just have an add, and that's all. Let's do the following at the moment. Let's create a new state of the model where entries will be equal to entry list.append model.entries, and the thing that we're gonna append is a string of new task. So basically what we want to achieve here is we're just gonna return a new model with a list of entries and a new task appended at the end of this list of entries. To make it a little bit more clear, let's define actual let and new entries, and let's just copy this over so it's more readable. Let's do in. So each time we press enter, the new task will be added like a new task. Here, why do I have this list? Because append accepts two lists, so it combines them together, and we just need to add one element. So as you can see, it just works with enter. But of course we need to keep track of what we have in input, and let's do that. So let's in fact add another message. Well, I'd say actually let's start of thinking about our model first. So let's say current input is a string. So this will start to complain because we haven't specified in the initial state our thing. So current input is equal to empty string, and let's add a message. Update inputs, and immediately update function starts to complain. Actually, here we want to receive a string argument for this type. So update input will have in its type, it will have a string. So the value of this input box basically. So new okay, input value, let's call it like that, and let's record that into the model. Alright, so we have created all the necessary types, messages, model, but we haven't actually made anything that could make this call from HTML, make this send this message in the HTML. So let's do that.
Current in out.
Sorry?
Current in out.
Ooh, input, current input.
That makes a lot more sense.
Yes, thank you.
The strange thing that it wasn't like bringing you a compiler.
I think I didn't press save, that's why.
Oh.
So here we can just say on input and add this update input message. So on input actually will provide this current input to our type. So you wouldn't be able to give it a type that doesn't have a string in its type definition, if that makes sense. So if you say, for example, add, let's say we have add here on input, it will say that this type expects a string alongside with a message, but we only supply the message. All right, so this should actually work. Let's explore our history, and you can see that here we have current input as a last step, like 13. We have it here. So in our state, but it actually doesn't really do anything because we haven't yet specified that we need to update our list of tasks with the current input. Let's do that.
Can you please commit that code?
Sure. Let me do that real quick. Okay, you can pull latest master with all this stuff. Please tell me when you're ready. I need to drink some water as well, so. So everyone's ready? Cool. So in the add message we logically want to make use of this input value, right? So let's do that. Here we can just say model current input, and it's just gonna work. So hello, it has added hello, world, it has added world. The next thing obviously that we want to do is we want to remove this input after we press enter. We don't want to each time to manually delete this. So let's do that, and let's say current input is equal to empty string, and it won't work. Can anybody guess why? Hint is here. Hint, hint, hint. Okay. If I make it a little bit smaller, will you be able to see? So basically, we need to supply a value from our model to this input field. We need to make it sure that it basically binds a model to our input field, right? So let's say value, and it's going to be, okay, we don't pass a model here, so let's pass a model. And let's say model.current input.
Maybe we can hide sidebar.
Wow, I'm not sure how to do that. Actually, I think what we can do is we can just separate it into a separate lines. It's gonna be much more readable. So yeah, we want to say like that this specific inputs value comes from model. So now that we can say add to create a meetup group, it's gonna annulate this specific input. Alrighty then, I'm gonna commit this. Now, after this step, I can take some questions, and then we're gonna continue on adding completion. Then we're gonna add like ability to remove the task, add some filtering, and then local storage. So do you have any questions? Like, do you understand what's going on here right now? Is everything super clear? And is there a part of application except JSON parser that you don't understand? Cool. Now what we're gonna do is we're gonna add ability to remove a specific input type. Or actually no, we're gonna add completion, because that's a to-do task and removal is a secondary feature. So we're just gonna have ability to complete or uncomplete a task, I'm not sure. So basically check a task either to completion or not. So let's start thinking about our model for a second here. We need to identify which task actually we have clicked, and we need to keep track of some kind of ID here. We don't have that at the moment in our model, so this is a place where I think we should have a type for our to-do entry. So let's define that. So let's say type alias, and let's say entry. And the entry will have a description, and it will be a string. Let's start with this, just define a type and make it work across the application. So our model right now is a list of strings. Let's make it a list of entries. And you can see it immediately fails here in our initial. So model is list of entries and it fails in our initial function. So let's do that. Let's fix that. Let's say entry. And here let's say entry as well. So this does fail. Actually, let's do it like this. Description. Okay. Right now compiler goes crazy because we don't actually have a correct return value from one of our functions. I think this is a good place to add our type definitions, because compiler starts to get wacky and it doesn't understand what we are trying to pass it. So let's do that. So view accepts a model and returns HTML MSG. So immediately we see where the problem lies. So here the same model HTML MSG. Here the same. So show header. here will be show entries and show entry. So basically what this says is okay, we accept a model as our input and return HTML that can potentially return messages, and that's all. So, and as we see, our problem is here, since we have defined an entry to be a record, a map, if you wish. So we can say entry.description. Ooh, this is not a model, it's an entry. Now it should work. And it still doesn't. So it expects an update to be... Okay, let's do this. MSG. And it will return us a model and a CMD MSG, I think it was like that. Alright, so here is the problem. We added this current input, but it's not the entry that we expect. So as you can see, like, okay, so these message, basically not message, but type signatures are optional, but they help you a lot with dealing with this, what is happening here. So let's create this entry with the description. Alright, so this works. You see, undefined. But that's because it recompiles and it keeps the old state, and sometimes it just goes wacky because of that. So that works, and we have successfully added a new type, the type of entry. So now, as we spoke before, we need to keep track of an ID somehow. So let's say the current ID. We need to keep track of current ID on the model. So each time we add an entry, we can increment that on the entry. UID will be an integer. So it should start to complain right about now. Yes, it does. So let's add. Okay, this is getting a little bit cryptic, but we will. Let's do a empty model. It won't be empty at the moment, but we don't really have a problem with that. So let's say empty model. Let's just separate these. And so current UID. Since we have two tasks, we need to probably say that the index will be 2. The current UID will be 2. So the next thing we probably need to do is add a UID to a specific task. So this is just to keep track of which UID is at the moment. So each entry will have its own UID. So this fails again, and why does it fail? Because we need to add UID as well. It's going to be 0. All right. So here we need somehow to add this current UID. UID will be equal to model current UID. And of course we need to increment this UID as well. That's alright, this is a little bit mouthful, so we're gonna extract this. All right, so we have added like a notion of individuality to each task. Basically, we know how to differentiate them. So let's start by implementing this on-click functionality that will allow like to complete this task or uncomplete it. So the model is fine right now. We need a new message, so let's do that. Our new message will be check, and it will provide us with UID, which is an integer. And of course compiler fails, and we start writing our check message with UID. So what do? Basically we go through all the array, and if the ID that is passed matches, then we update its completion. Either like if it's completed, then we uncomplete it. If it's not completed, then we complete it. So let's write a function for that. Let check entry, and check entry will accept UID. It actually has a notion of UID, so we can just say entry, and if entry.uid is equal to UID, we say entry is completed. Let's do it like this, entry, and so basically if you're wondering what this pipe operator does, is basically it combines two maps together. So is completed is equal not entry is completed. So it will fail because we don't have is completed on our entry. So let's add that. Boolean. Okay. Let's add then else. And else, if it's not UID, if UID is not equal, we're just gonna return entry. And let's supply in block, and in block we just do a new. Let's do it like this. Add new entries. So new entries will go through list of entries. Map check entry. So we supply this check entry function to our list of entries. So, and let's return our new model with entries, new entries, and cmd.none. So this will fail again because we don't have we haven't supplied is checked here. So obviously, like if we add the new entry, we say it's not checked or is not completed. False. So empty model as well doesn't work because we need to say is completed. False. Actually, let's stop doing that because we can I don't want to maintain that. Let's delete our code. So we don't really care about like having predefined values in our entries because we already can add them.
UID needs to be changed from 2 to 0 then.
Yes, true. It won't hurt, but to be pedantic, it will help. So, and now we need to add this checkbox that actually checks this thing, right? So let's do that. Let's do that in our specific entry. So first of all, it's gonna be a input with a type of checkbox, and on click it will call check with UID. Check with, oh, I don't need equal sign here. Check with entry UID. We need to add the parentheses here because otherwise it will blow up. Input. So what has gone wrong? Okay, so I need a comma here. All right. So this should actually work, but it will not change anything because like if we check, like it doesn't really do stuff. Oh, and we need to add class here with toggle. So we can basically click on it, but it doesn't change state of the app. No, it does change state, but in that, well, nothing really happens because we haven't displayed that in our HTML view. So let's do that. So let's say let completed class. So what we want to do, like we want to supply a class name to our list item. If it's completed, like then it's completed class. If it's not completed, then we just supply an empty string. Let completed class is equals to if, actually we can do it like, yeah, if entry dot is completed, then we're gonna return a completed class, else we're gonna return an empty string. And let's supply in block. Okay. My editor actually auto formats many things, so that's why it might seem that I'm super fast, but I'm not. So completed class. Now let's apply this to our list element, class and completed class. So as you can see, it actually works. We can complete it, and the changes are reflected in DOM. The only thing that I will add here once more is a checked attribute, so that we know that it's checked. For example, if we pass a new state and it has checked, like basically what we did before with an input value where it's generated from our model. Right now it's not generated from the model, this one. All right. Hello, it works again. So, okay, cool. So we added ability to complete things. I'm gonna push this forward. Is everything clear so far? Are there any blind spots that you might not understand fully? Please go ahead, ask questions. Is everything understandable? I just did it, and I already pushed to master, yes. And it's deployed to production, and it's generating our revenue, so. Alright, so let's add deletion. Okay, so we need a button. And the button will have a class of destroy. Let's check if it actually is there. Yep, it's here. Nothing happens when I click it. So we just added a simple button, and now we need to create message to actually handle it. Let's do that. Let's add another message type, remove entry, and we're gonna supply it a UID. So remove entry with UID, and let's open up our let block with new entries. And the way we remove a thing from a list is by a list filter. And we supplied anonymous function. So what is an anonymous function? Well, probably you all know, like lambda. Have you all seen it? Yeah, probably you have. So the way it's written in ELM is a backslash, and it should be in curly braces. So, and then an arrow, and then it's everything that happens after that is a function body. So we can say e is equal, e UID is equal to UID. So that will get removed because it will return true. And we need to supply it with model entries. And let's open up in block. And let's say we get model returned with entries equal to new entries. And cmd.none. Oh, okay. Double equals. So this should work, but we need to supply it to our onClick event here. OnClick, remove entry with UID. Entry.UID. Okay. So this works, and this for some reason doesn't. Let's see if we failed somewhere. I think it might just delete. Yeah, it deletes everything else. So we need to. What we need to do here is not. Oh, not here, but here, not. And of course the braces. Braces everywhere. So we need to delete world, and it gets deleted. So we fixed that. Now the next question is, guys, do you want to work on filtering as well, or do we just add local storage and be done with it? Yeah, it won't be anything. There's not going to be any magic there. Just following all this because like it's just going to be clicking on a button, adding a new filter, and then it's just gonna work. All right, so let's do the following things. I'm gonna copy over this snippet. So we have index.js file here. So stored state. We get stored state here from local storage, ELM to do save. Then the starting state is either parsed value of this stored state, or it's a null. Why do we need to do this magic? Because like ELM doesn't accept undefined as a method, as an argument. You have to either supply null or a valid data structure, so to say. So, and we launched this Todo MVC with a full screen option and starting state. So starting state will be null at this moment because we don't have it. And if we save it, it will say that Todo module does not need flags. So what we need to do here is we need to say program with flags. So, and it will fail because initial function, init function, expects us to basically say, expects us to have input from JavaScript. So we can say model, and it's going to be maybe model. And here we need to say it like this. Maybe dot with default. So empty model is going to be a default one, or a model. I think it was like that. So it does complain. Okay. Let's see what has gone wrong here. Init something with the types. So it expects initial function to be so it's interesting. We supplied initial model with a model like with flags, but it doesn't still recognize it. Sometimes that happens. Let me double check this. Oh, okay. I do know what's wrong. I'm gonna maybe model and then we return the model. Now it works. So obviously, like, it won't have any effect at the moment because we return null from local storage. It's we don't have anything there, so let's persist that. And the way we do that in ELM is basically with ports. So port set storage, and it's gonna have a type signature of model and command msg storage. I have a typo here, and we need to define it as a port module. Otherwise it doesn't work if you don't specify it as a port module. So the next thing we need to do is basically take this set storage, and on each function call we need to call this port. We can do that by just saying, like, for example, removing CMD none. But it fails. Why does it fail? Okay, let me quickly try to add this here. Set storage with oh, we need to pass a new model. So the problem is that we probably need to somehow save this and call it new model, and we need to call set storage with a new model. Alright, so now it will work, but it's a little bit tedious to do that this way, because like we have to you know, supply a new model to set storage function, and as well we need to supply a model to return it from update. So it's what we can do is we can just create another function with set storage, update with storage, CMD none, and let's call it update with storage, and it's gonna accept a MSG, and okay, so it's gonna accept message and model, no, model and CMD command. So we're doing pattern matching here. We know that this will be the call to this function will be a model with the okay, I'm gonna need to explain pattern matching. I think I'm gonna fail miserably at it, but so yes, let's basically write this function, and then I'm gonna explain what's happening there. So let's say MSG model, and let's do it update with storage, and let's do it like let new model CMD equals to update with MSG and model in, and now we just need to return this new model and tell ELM to execute our any commands that we send to it, and our persist storage model. So we're gonna do CMD batch and CMD comma and set storage new model. Alright, so this did compile. So a little bit about pattern matching. So right now we changed update with storage on our update function for HTML program with flags, and we call an update function inside of this function, and the result is a tuple with a new model and a new command that this needs to execute. At this moment we don't have any commands that we need to execute, but for like future you might want to do that. So and then you say like, okay, return a new model and execute this batch of commands. So at this moment we don't have here, so it's gonna just probably work. So let's see. And let's refresh, and it updates from local storage. Let's, just in case, let's delete the local storage. Here is to do save. Let's delete that. So it's empty, it works with no state at all. Refresh, it works. Let's check it. It works. It works. So that's all. I'm gonna commit this code so you can so just to recap, we created a port that we can interact with. Each time it's set storage is called from ELM side, it's gonna return our state, and we just persist it in local storage. And as an initial state of the application, when we load it, we just get values from local storage, either return null or the JSON object, and provide it with an initial state. So here, in to-do application, we define set storage function. So set storage is just a port, so it accepts a model and returns a message. And that's all. That's all you need to do to interop with JavaScript. So thank you.